In this video I'll walk through how I set up my probe hardware and tooling to get started developing the probe code. I'm going to be using an esp32 microcontroller. I will set up a development environment using a project managed in Vscode. The overall project will be a clone of an Angular starter project I use for my UI development, with an added folder used to hold the probe specific code. In VScode I have loaded the PyMakr extension to help interfacing with and running code on the esp32. I'll also show how I download and flash Micropython image onto the esp32. Yeah, I'm just outside Micro Center. I just got one of these esp32 board, so that's what I'll be using for my ourProbes first probe. You can also pick up the esp32 board from Amazon. You see this one here is $10.99, which isn't a bad price. A common problem with the esp32 development boards, it's something you see a lot of out on the web, is the need to put a capacitor between the EN and ground pins so that automatic flashing occurs when you reflash the microcontroller. This shows what it would look like on the board. I actually am doing it on a breadboard, and also put a link there if you want to find out more about the problem and the solution to that. I'll be using Micropython on the esp32 microcontroller. It acts fairly much like an interpreter. Lower level, it's actually compiling the source code that resides on the esp32 into virtual machine code. But you'll find that it's mostly like working with an interpreter. I'm going to use my FBM starter Angular application as the user interface for talking to the probes. So I'm going to start a new project by cloning that template. As you see here, I'm in an FBM starter. I'm going to create a new project called ourProbes, which is a clone of the FBM starter application. FBM starter application is one I created to start Angular applications. It has a lot of things built in, like connections to Firebase, material design, support for PWA, a whole lot of goodness that I use in all my Angular applications. Okay, in GitHub I've created a clone of that FBM starter application called ourProbes. You see it generating now. Now I go into the ourProbes repository in GitHub, and I'm going to get the link to clone the ourProbes repository down to my local VScode and development machine. So I'm bringing up VScode now. I'm going to call up the option to create a new project by cloning from a repository. I put in that repository string that I collected from GitHub. I need to tell it where the new project's going to live, so I'm going to keep it in on my machine in my C projects directory. Under that I'm going to create a new ourProbes folder. So VSCode will go through and pull down a copy of or a clone of that repository on GitHub. So now when I open that new project, I've got a fully populated Angular application. The next thing I need to do with the FBM starter applications, or things created from the FBM starter application, is do some global replaces of certain keywords. So I've got keywords in the application called FBM starter and FBM -starter that need to be renamed to the new project name. So here you see I'm in VS Code just doing a mass change on all the files of FBM starter to ourProbes. Okay, there's about 70 replacements here, and I'm also doing a change of FBM-starter to ourProbes. Now I should have a good starting project for all the Angular work I'm going to do for this as well. Final thing I'm going to do is, under the source folder, I'm going to create another folder just to hold the Micropython code. for this project. So I'm going down into source, I'm creating a new folder. Just a note here, I actually called it Micropython in this video, but I changed it to call it probe. I thought that was a better name for the code for my probe. So I'm keeping this code in that ourProbes VScode project. This diagram is an overview of the development tools I'm using. So for flashing Micropython to the esp32, I'm using the esp tool, and then for the actual coding, I'm using Vscode and an add-in called PyMakr. The next videos are going to show details how I install and use esp tool. So first I'm going to get a copy of the Micropython image. For that I go to the Micropython website and downloads, and then I'm going to use the generic image, the second latest. So I've downloaded that. Now I'm going to install esp tool by doing a pip install esp tool. So you need to have Python installed for the pip to work. I've already got esp tool installed, so that's what it's saying there. Next thing I need to do is flash the esp32, so I use esp tool and flash the esp32. That basically clears all the flash memory. Once that's complete, I'm going to flash that downloaded image of Micropython. You see that's the last parameter in this command to the esp32. Now this can actually take a while. I've shortened it here. Okay, this looks at VScode and how I'm using a add-in called PyMakr. So first let's see how we install the add-in or the extension to VS Code. I've already got it installed here, but basically what you do is go to the extensions, type in PyMakr, and it shows up there, and you can click on that to install it. I've already got it installed, but it tells you what it does is add a REPL interface to your VS Code, and you actually see it running down here, my REPL interface to my esp32 board down here, which is shown in this window down here. At the moment I'm connected through COM3. When you've installed PyMakr, it gives you a set of commands that can help you code on an interface to the esp32 board. So just give you an idea of what all the commands are. So you can do things like list all the serial ports. On my machine I've only got one serial port running, which is connected on COM3. The other thing you'll need to do, and this when you first install it, it'll bring this up for you, is go to global settings. So this is where you define the interface to your esp32 board. I've put into address COM3. You've got a choice of having it auto connect, so it'll try and detect which COM port the board is on, in which case auto connect should be true. In my case I just found it more reliable to actually enter the address once, COM3, and turn off auto connect, and so every time my VS Code IDE starts up, it'll connect through to COM3. You can see it there is connected. You can do things like click on the PyCom console, so they'll reinitiate connection, so you see I'm actually connected to COM3. Then you can do things like run the current file. So if you've got a Python file here, it'll run it. So it'll actually upload it to your board and run it. You can also download, you can sync up your projects. I'm going to show a few of those things and just show you how I can get the light blinking thing. That seems to be the hello world of the microcontroller world. So I'm going to go to my VS Code project. I've got a whole lot of code in here, which is the Angular code that I'm going to use later on for my interface to the Google Cloud services that are going to connect to my board through IoT. We don't need to worry about it at the moment, so my plan is to put all the code for my actual board into this probe directory or folder here. To have that happen, I want to set up the sync folder. So in my case, it's going to be source probe. So I'll put that into the global settings. I'll save away the global settings. Now everything should be working out of that source probe folder. Let's try making some code. So I'm going to go into the probe here, create a new file. I'm going to call it blink.py. So that should make my blink.py file. So here we are. I'm going to copy in some blinker code. So here's some blinker code I've got for an esp32. I won't go through what the code's doing, but it's some Python code. Some of the nice things about doing this in VScode is because I've put the Python IntelliSense into it. I get color coding and IntelliSense behind all the code in my editor. Let's try sending this out to the board. So what I'm going to do is click on upload. So here it's writing out that file I was on to the board. It actually cleared out any other files that happened to be on the esp32 beforehand. Resets the board, and I should be able to run that, and you can see the blinkers running on the board. I can break into the board and reinitiate the PyCon console. I can do all the normal things like print and because it's interfaced to the board replies, and I see it on the REPL console as well. Okay, now I should be ready for doing some coding. So next up in the next videos, plan on getting the ping or ICMP ping logic going on the ESP32 board, and do some timings just to make sure that the latency numbers that come out of the ping will be usable for getting network capability measurements on bandwidth as well.